Oh, look what we have here. Okay, QF-2, shifted form of a parabola. A parabola is another way of saying quadratic. Okay, so a quadratic is a parabola. All right, so this is just some basic recall. Turning point, well, that's where this thing either goes from increasing to decreasing or decreasing to increasing. So if I look down here, I'd be decreasing, 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 and then I hit this point and then I start to increase. So this thing right here is my turning point. So that is 1, 2, 3, comma, 1, 2, 3, 4. So this would be 3, negative 4. Is this a maximum or a minimum? Well, this thing down here looks like it's going pretty low and then it goes back up again. So this is a minimum. A maximum would look like this. It would have a maximum value. This one has a minimum value. And is this concave up or concave down? Well, this opens upward, so that would mean this is concave up, not concave down. And the zeros, very important to know. What are the zeros? Well, the zeros are where my y is 0 or where I cross my x-axis. So my zeros occur at x equals 1. 1. So 1, 2, 3, 4, 5. And x equals 5. Okay. So these bad boys are my zeros. Okay. That was nice and quick. Number 2, which of the following could be the equation of this quadratic shown? So here's another parabola, and I want to know the equation. So the first thing you should notice is that this is a frowny face, and frowny face come from negative people, and negative people have negative signs in front of them, aka the A value is less than 1 or less than 0, I guess I would say more technically. So you're looking at a negative number because these ones, these positives, well, they're positive and positive people smile. So those would be looking something like that. The next one we have to think about, so it either has to be 1 or it has to be 3 because both of these are frowning. Now, how do I decide? Well, let's look at this y-intercept. Right, it's right here. Okay. Well, again, just like if we had a line where y equals mx plus b, right? And we said, well, let's cover how we move, and the b stands for where we begin. Well, it's the same thing. So I would say I'm going to cover how I move, and this tells me where I begin. So the y-intercept on this function would be negative 5, and the y-intercept here would be positive 11. Well, is this y-intercept positive or negative? Well, it's in the positive portion of the graph, so it has to be number 3. Reasoning, A is negative. So we can say concave down. And y-intercept is positive. Okay, so I have a positive y-intercept with a negative a, and the only one that tells me that is negative a, positive y-intercept, number 3. Okay, so let's talk about the goodies today. So consider the parent function x squared. It is graphed right here. This is your parent function x squared. The more complex function g of x equals x minus 2 squared minus 4. Let's put this on the graph. Oh no, I need a calculator. Hold on 1 second. Okay, so if I want to put this thing on the graph, let's go to the y equals. I'm going to do parenthesis x minus 2 squared minus 4. Okay, I want to look at the graph just because I know it should look like this when I'm done. Okay, so it looks like this one, but it's like over to this area. So let's get some points. Let's get some positive points and negative points. This 12 is way too big. So let's start with negative 1, 5. Okay, so I'm going to have negative 1, 1, 2, 3, 4, 5. Okay, right, what's next? 0, 0. Okay, what's next? 1, -3. 2, -4. 3, -3. 4, 0. 1, 2, 3, 4, 0. And let's throw another one on there, 5, 5. 1, 2, 3, 4, 5. Okay, so let's graph this here. Alrighty, let's name it. So this is y equals x minus 2 squared minus 4. Okay, it's on our graph. We're good to go. Now, what does our question ask? It says, how would you need to shift the graph of f of x to get the graph of g of x? In other words, how would I have to move this graph right here, f of x? How would I have to move this so it would lay right on top of this? Okay, here's the trick. What you want to do is start with your turning point of your original function. So your parent function f of x. So if I look at this parent function, I'm right here. And where's the turning point? The turning point is right here. Okay, so how would I have to move this turning point here to match the turning point here? So I'd have to go down 1, down 2, down 3, down 4. So this would have to be moved down 4. And then I'd have to go to the right too. And moving to the right is positive. Okay, so I would say I'm going to move turning point down 4. I guess I'll say and right 2. Okay. Well, what is the turning point of g of x, and where do you see it, in quotation marks, the turning point in the function's equation? So the first thing, let's identify the turning point in g of x. Okay. So turning point of g of x, remember that's where I'm going from increasing to decreasing or decreasing to increasing. I'm at 1, 2, comma, -4. And it also says, where do you, quote unquote, see that point in the function's equation? So let's rewrite the function g of x's equation. Okay, well, let's look really closely. I do have a 2 and I do have a 4, okay? So if you're given the equation, how do you know how this is shifting? We call this opposite x, same y, okay? Because notice if I look at this x value, it says -2, but this is a positive 2, okay? So we're going to say opposite x, same y, okay? Because if I look at this -4, it's the same as this -4, okay? So if I'm given an equation, I know the turning point, if it's in vertex form, as opposite x, same y. That means the number with the x, I would take the opposite of that sign and the same y value, okay? So now let's look at a little bit of a different shift, alrighty? So the first thing I want to do here is consider the quadratic function y equals x squared plus 2. And now I want to look at x squared minus 4. What do you think is going to happen when I put this into my graphing calculator? So remember, this one here is f of x equals x squared. Okay. And let's look at x squared minus 4. Let's look at this graph. Oh, okay, well, it looks really similar to this one, but it's not on that 0, 0 point, so it did a shift, okay? So let's get some points here. 12 is too big, so let's start with -3, 5. So -1, -2, -3, +5. 1, 2, 3, 4, 5. Alrighty. My next one is -2, 0. My next one is -1, -3. I would have 0, -4. I would have 1, -3. I would have 2, 0. And that means I would have 3, 5. Okay. I have this nice parabola here. And this one is y equals x squared minus 4. Oh, well, this looks very similar to this one, only it's shifted down a little bit if you notice, right? So like we did before, this is the turning point of this one. If I wanted to match the turning point of this one, I would go down 1, down 2, down 3, down 4. So this, I don't have to shift right any. I just have to go downwards 4. So what was the effect of adding a constant to the overall function? Okay. Oh, darn it. Let's do x squared. Let's look at this one too, I guess, so we can really see it. So I'm going to put y equals x squared plus 2 on here now. And after we just talked about that, I hope you have an idea of what it's actually going to do here. So this one went down 4, but this one looks like it's going to have to go up a few, okay? So I'm going to get some points here. I just put in my y equals. So I'm going to do -2, 6, -1, -2, 1, 2, 3, 4, 5, 6, okay? I'm going to do -1, 3. I'm going to do 0, 2, 1, 3, and 2, 6. Okay, so this one is y equals x squared minus plus 2. Okay, so basically it says, what was the effect of adding a constant to the overall function? Remember what our quadratics look like. Ax squared plus bx plus c. Notice in both of these functions, you don't have a bx term. Okay, you just have ax squared plus c. So this constant is what it's talking about in this question. Okay, so what was the effect of adding a constant? Okay, well, what happens when I added 2? How did I move up from my parent function? Okay, well, when I added 2 as a constant, it moved the graph 2 units up. Moved. Okay, it moved y equals x squared up 2 units. What happens when I did x squared minus 4? Okay, so when, I guess I should do x squared plus 2 to be consistent. So x squared plus 2 moved the graph y equals x squared up 2 units because I put a plus 2 on there. This one moved it down 4 because I said minus 4. Okay, so what we notice here is that when you're adding to something that's not connected to the x, this is how you're moving up or down. Okay, so this will tell you moving up or down. Next to the x is going to tell you if you're moving left or right. So state the coordinates of the turning point of each of the parabolas. So let's look here. What was my turning point of x squared plus 2? Well, here's x squared plus 2. My turning point was this thing right here. So the turning point looks like x was 0 and y was 2. What a coincidence. Okay, x squared minus 4. Okay, well, where's the turning point for x squared minus 4? Here it is. What is the turning point? Well, the turning point is when this goes from decreasing back to increasing, which is 0, -4. 0, -4. 0, -4. Because notice I didn't add anything into this x like I did here to make it a horizontal shift. Okay. All right. So now, without even looking at a graph, what would the coordinates of the turning point of the parabola x squared minus 150 be? Okay. Well, what is the x? Is there anything added or subtracted into this x? No. And I just bring this y or c value along for the road. Okay. So 0, this is your y. 0, this is your y. Alrighty, so this is going to be the last one that we do here. It says now consider y equals x plus 3 squared and y equals x minus 1 squared. Yet again, the parabola x squared is graphed below. Using your calculator, generate tables, sketch these two quadratics, and label. Okay, so the first one I'm going to do is x plus 3 squared. Okay, so it looks a lot like this one. It's just shifted a little bit. So let's get some points here. So let's start at -5, 4. So -1, -2, -3, -4, -5. 1, 2, 3, 4. -4, comma 1. So -4, comma 1. -3, comma 0 is right there. -2, comma 1 is right here. And -1, comma 4 is right here. And that's that. So this is y equals x minus 3 squared. Let's put this other one on here. X minus 1 squared. Oh, okay. So here we are over on this side. So let's get some points here. Looks like we're going to have to start at -1, comma 4. Oh, it's on this graph. 0, comma 1. 1, comma 0. 2, comma 1. 3, comma 4. So this is y equals x minus 1 squared. Okay, so we have two graphs and we have our parent function. So our parent function started at 0, 0. How would I have to move to shift to the left over here? 1, 2, 3. So this would be -3 to the left. This one would be +1 to the right. Okay. So why is horizontal shift counterintuitive? That means that it goes against what you really think it's going to do, okay? So if I did a horizontal shift, I know it's a horizontal shift because horizontal shifts happen when you connect it onto the X. Vertical shifts happen when you connect it on the outside of the X, okay? So this horizontal shift, it came all the way over here and it ended up shifting to the left 3 units. But this is a plus, okay? So opposite of what I thought it was going to do. This one says x minus 1, but when I shifted it, it went to the +1, okay? So it goes the opposite way that this sign tells you, okay? So it moves, shifted graph, the opposite of sign. Okay, so what does that mean? It means, well, here I am at 0, 0. If I say x plus 3, it actually shifts the graph left 3. Okay, if this says x minus 1, it actually shifts the graph +1. Alrighty, So state the coordinates of the turning points of each of the parabolas you drew. All right. So what is the turning point on this one right here? So the turning point, the x value is -3. The y value is 0. And what about the turning point on this one? So the turning point here, the x value is 1 and the y value is 0. Okay, and why is that? We already talked about this. Opposite x, same y. Okay, there is no y value here. Okay, there's no shift upwards or downwards. It's only left or right, and that's what happens on the inside of that squared function. So opposite sign for x, so the opposite of +3 is -3, and 0 for y. Opposite x, so negative, turns into a positive, same y. So determine the coordinate of the turning points of each of the following quadratics. Excuse me. Okay, all we need to remember is opposite x, same y. Okay, this is the idea. Opposite x, same y. So the turning point, opposite x, so the opposite of -8 is +8, same y value, so same y. Okay. Opposite x, so here's +1. The opposite of +1 is -1. Same y, so -4. What about this 5? Does not matter. It is irrelevant. It is strictly telling you if this thing is concave up, concave down, skinny, or fat. Okay. Turning point. It has no relevance on the actual turning point. Opposite x, so the opposite of -3 is +3, same y. And, ooh, this one's a good one. So what is this one? Opposite x, well, I don't see anything in the x. Okay, well, if nothing is being added or subtracted to it, it's a big fat nothing. Okay, and what about, oh, nothing is being added. 0, 0. Okay, opposite x, same y. There is nothing being added to x. That means it's 0. And the y is also 0 because I'm not adding anything to a vertical shift. Okie dokie, samakis, goodbye.